Now let's combine our translations in what we've been talking about so far and go through some steps and look at one more example where we're going to do it all on this one. You can see that I've recorded for you or written down I guess they would be the parent functions for both sine and cosine, showing you the amplitude, b, which gives us an indication for the period. We have our vertical translation, which is outside of the function. And we have our phase shift, or the horizontal shift, which is inside of the function. Now I have listed for you here in this table two methods in which you can graph our trig functions. The first method is going to walk you through using the table method. The second method, which is the one that I tend to use, is the translation method. So let's look at this example right here. This one says I would like to graph -1 plus 2 sine of 4x plus pi. Now I hope that you recognize that I have a number next to my x variable here. And it's not, in other words, this is not in the form that I want right here. I need b to be factored out. So let's go down here and we're going to rewrite this equation so that it looks like y is equal to -1 plus 2 sine bracket. Now we're going to factor a 4 out, or in other words, I'm going to divide both of these terms by 4. So if I take that 4 out, that leaves me with x plus pi over 4, because I divided both terms in there by 4. Now this is in the form that it's most useful for me to translate. So we're going to identify our pieces. We start with A, right? A would be the amplitude. It's a +2, so we know this is a regular function, or it's not flipped, in other words. So A would be 2. Next on the list, let's look at B. B was 4 because we just factored that out. So the period would therefore be 2 pi over B, 2 pi over 4, or in other words, pi over 2. So what we're looking at is an interval, in other words, that's between 0 and pi over 2. Now let's just identify everything first. The next thing I'm going to identify is the inside portion right here. This tells me that I have a phase shift, okay, and I'm going to shift everything by the opposite. In other words, I'm going to shift everything by a negative pi over 4. Okay, so we have a phase shift of a negative pi over 4. And then finally we have this number that's just kind of hanging out here, where we have a vertical shift down by 1. So we have a vertical shift down by 1. What we need to do, since we have a new period here and we have a phase shift, the next thing that I like to do is go in and divide up my period into its intervals. So if I'm looking at a period between 0 and pi over 2, let's divide that up first. So we know that halfway between 0 and pi over 2 would be pi over 4. Half of that would be pi over 8. So if I'm incrementing by pi over 8, then this part right here would be 3 pi over 8. So this is my interval, which is my period, right, which I broke up. And now I'm going to come in and I'm going to shift my intervals. This is where I'm going to do the shifting part second. So I'm going to come in and I'm going to subtract pi over 4 from each of these values. And I won't bore you by writing it, so I'm going to pause the video and I'm going to record my values. So when I just come in and do the straight subtraction on this, these are the new values that I get for my interval. In other words, these are the values I'm going to mark on the x-axis because I shifted everything to the left, or in the negative direction, by pi over 4. So now we're kind of ready to start setting up our axis. I'm going to draw that down here. I have a period occurring between negative and positive pi over 4. So that's like this. So I have a negative and a positive pi over 4. halfway in between is 0. So we mark these other sections with a positive and a negative pi over 8. Okay? If I want to continue in this direction, if I continue my period in the positive direction, then I can graph an entire another period by adding pi over 2, because that's what the period of this function is. I can graph an entire another segment, in other words, by adding pi over 2 to 1/4. So what is 1/4 plus 1/2? Well, that would be 3/4, or 3 pi over 2. Okay? So then we mark this up, knowing that every time I advance, I am incrementing by pi over 8, right? Because we've already said that here. So every time I move, I am incrementing by pi over 8. So if this is 1/8, 2/8, this would be 3/8, 4/8, which is pi over 2, 5/8, and then 6/8, which is 3 pi over 4. So we can draw 2 entire periods in this manner. Okay? What else do we know about this function? We know that we have a vertical shift down. So I'm going to look at everything. I'm going to take that x-axis, and I am going to shift my x-axis down by 1. So let's kind of make this bigger so it's out of the way. So I have a -1 here. Just to be consistent, we have a +1 there. So I'm going to draw my imaginary x-axis, or my shifted x-axis, down there. I also know that my amplitude is going to be 2. So off of my shifted axis, okay, off of the shifted axis, I'm going to go up 2 and I'm going to go down 2. So when I'm marking off the y, then I come up here, this would be 1, 2, so I'm good there. But I'm going to go down 2 more, 1, 2, to -3. We know that this function is a regular sine function. It's not flipped or anything, so at this point it looks like I'm ready to draw the picture. So sine function. Sine is going to start on my x-axis, which is this blue line. It's going to rise up here, because I have an amplitude of 2, so it's going to rise up here. We cross here at 0. We go down 2, so we're down here, and back up. Now that was one period. Remember, we said our period was between negative and positive pi over 4. But we're going to keep going. So we're going to finish drawing this function. Now that we ended here, we're going to go back up top, cross, down low, and come back and finish right there. So we have our curve of our trig function going like this. It's kind of stretched out according to my graph. It's not the prettiest, but I think you get the idea. So this is a combination of what all we've done so far, where we have a period where we've condensed the period, then we shifted everything to the left, and we shifted everything down. So that's what it would look like when you do all of those shifts.